Smith, am I audible?
Yes, Tushar, you are audible.
Okay, guys. So, hello everyone. Am I audible to all of you?
Yes.
Yes, sir. Yes, you're audible. Okay. Algorithm team, are you there?
Yes, we are here.
So when you're going to start with the live session, so just let me know.
Yeah, we are already live. We can start.
Okay. Okay, so guys, I welcome you all to the Machine Learning Bootcamp, which is organized by Google Developer Student Club of Amity University, Mumbai, in collaboration with Algorythm. Okay, so the speakers for this 15-day Machine Learning Bootcamp are myself, Tushar Sharma. I'm the Google Developer Student Lead of Amity University, Mumbai, and also I'm the Machine Learning Crowdsource Facilitator at Google. So after that, we have Smith Kumar Bhattesra. He's a GDSC Core Committee member, and he is also a mentor at Winter of Code 2.0, which is a open source event. Okay, so I will just share my screen and I'll show you what all we are going to cover in this 15-day Machine Learning Bootcamp. So just give me a minute. I guess my screen is visible.
Yes, Tushar.
Okay, so first of all, I'll just show you what's the whole program structure. So today is the first day, so I'll be giving you a glimpse of what is actually machine learning. What do you understand by the term machine learning? And once that is done, Smith will be starting with the basics of Python. And we will take 2 lectures for this particular thing. Once that is done, we will move ahead with some basic mathematical concepts which are required for machine learning. After that, we will teach you some machine learning models which are given on the screen, and once that is done, a project will be assigned to you which you have to complete, and the one who completes the project and he makes the best one, so he'll be getting swags and goodies from Google Developer Student Clubs as well as the Algorythm team. So I think this much is pretty clear. So anyone has any doubts or any questions?
Will we be getting any certification or something from this?
Definitely. At the end of the session, once you have submitted your project on our GitHub repository, you will be getting a certificate on your mail.
Okay, thanks.
Does anyone have any questions regarding the program structure? So do you guys think should we cover anything else apart from the things which are mentioned in the program structure? If you feel so, please let us know. So are we good? We are on track? I take it as a yes. So let's just start with a small introduction to machine learning video, and after that I have one interesting question for you guys. Smith, is it audible?
No, Tushar.
Now can you hear it? Hello?
No, Tushar, it is not audible.
Okay, just give me a minute.
Tushar, I guess you have to share the specific tab.
Yes. Okay, so how many total lectures will be there? So we are going to have 15 lectures, and based on the requirements, if you guys want us to cover any specific topic in the field of machine learning, then we can extend it to 16 to 17 lectures. That depends on the requirement, and at the end we will be allotting with the projects. So those who don't want to attend that session, they can do their project.
When we're born, we know almost nothing.
Now is it audible?
Yeah. Yes, Tushar.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter, and find us on Facebook.
So I guess from now onwards you have a pretty a small idea about what is actually machine learning. So I'll share my screen again and let's just dive deep into machine learning. So yeah, here's a link of an application. So I'm sharing it in the chat box. So I want everyone to just install it. It's a very small application. It will just take a minute or so to install this application. So I request everyone to install this particular application on their mobile phones. Gagan, that's a surprise actually. You will see it by your own. So first just install this particular application. Just go to your Play Store or App Store and type crowdsource.app. Crowdsource. Just write crowdsource and you will see this particular application. Else you can use this particular link. So once you are done installing this particular application, just write a yes in the chat box. The session needs to be a bit interactive, so even if you unmute yourself and just say yes or just put it in the chat box. I can see people saying yes. Okay, that's great. Even I'll just open this in my phone. Okay. Yes. Just 1 minute more.
हेलो तुषार।
Yes.
मुझे ज्वाइनिंग के लिए लेट हुआ, क्या बता रहे थे और एक बार बता सकते हो?
The session is live streamed and the recording link will be shared in the group. Okay, so you can refer to that. So just first install this particular application whose link is mentioned in the chat box.
Hello?
Yes,
जो
sir.
लिंक शो नहीं कर रहा.
Okay, I'll share the link again. This is the link. So just install it.
Okay, crowdsource.
Hello,
Yes.
the app is not available on App Store. So is it necessary during the course?
It's not necessary. It's not necessary. It's okay. I'll show you what the app does.
Okay, I'll just install it in a simulator then. Is that fine?
That's fine. That's fine.
Okay, thank you.
Okay, so I guess most of you have downloaded that particular app. Okay, so just open that particular app and can you see the smart camera icon?
Yes.
Yes, so just click on that and install that particular thing. If you have installed that smart, I'm repeating again, just click on smart camera and install it. Is it done? So once you're done, just write done in the chat box. That's perfect. I can see many people writing done in the chat box. Perfect. For those who are not able to do it, don't worry. What I'll do is I'll just share my screen and I'll join through my phone. I get my screen visible. Is my screen visible?
Yes, yes.
Okay, so for those who are not able to do it, I'll just demonstrate it on my phone. Okay, now just navigate to crowdsource. Okay, click on smart camera. Okay, and aim at an object and just click on the screen and just let me know what do you guys see.
Bro, किसी ऑब्जेक्ट का पिक ले.
Yes, I know. Just give me a minute. Guys, can you see? As soon as I click on that particular thing, so this particular app is showing that is this a computer keyboard? Okay, so that's what I'm trying to tell you. This is what is machine learning. So the basic definition of machine learning is we are trying to copy human intelligence. For example, I know that this particular thing is a keyboard. How do I know? Because I have previously seen keyboards. That's why I'm able to tell that this particular thing is a keyboard. The same thing is done by this application. There's a machine learning program which is running in the background and which is telling that this particular thing which is scanned, it's a keyboard. Okay, so let me give you one more example. This was previously mentioned in the particular video that since childhood, how did you identify that this particular the animal is a cat or this particular animal is a dog? How do you identify that? Can someone answer this particular question? How can a little kid understand that this particular thing is this particular animal is a dog or this particular animal is a cat?
If it says bow bow, if it is nothing, is a dog.
Exactly. So that means your mind has learned. Okay, Rimchim. You want to say something?
Oh, it was the same thing. I know. No, it was the same thing. Like you asked, right? So I was just answering, but then somebody answered, so I just lowered my hand.
Oh yes, you can answer it.
No, it's like based on previous experiences. If somebody pointed out to a dog and told us that it's a dog, so we learn that it's a dog through association and observational learning.
Exactly. So that's what machine learning does. So we are training that particular program or algorithm that this particular image is of a dog and this particular image is of a cat. So if we supply many images in bulk quantity, the program automatically learns and it extracts some features. For example, a particular dog is quite larger, a cat is comparatively smaller. So that's one of the features which the program extracts out of the images, that in this particular way I can identify that this particular image is a dog or a cat. Okay, so this is how machine learning works. Okay, so let me give you some examples where machine learning is used. It's used in weather forecasting. It's used in websites. I think you must have known about chatbots and all. Okay, so those all are implemented using AI and machine learning. So I'll just share my screen again and we can go ahead. So are you guys clear with everything, whatever has been taught till now? Or do you guys want me to repeat it again? Okay, I can see yes in the chat box. So if you guys have any doubts, you want me to explain something again, so just let me know. Okay, clear. Right. So now after all this explanation, can someone give me a proper definition? Okay, so what do you understand by machine learning? I want to know your perspective. So can anyone just unmute or just write in the chat box, like what's your perspective of machine learning? Anybody?
Am I audible properly?
Yes, Ishan, you are audible. Yes, Ishan, go ahead.
Yeah. So I may not be able to put it in proper technical terms, but machine learning, in my opinion, is you give your computer a set of data and you tell that computer, hey, this data means this thing, and you tell it to remember it, and the next time you give that computer that data or something similar to that data, your computer tells you that, okay, from what you taught me last time, this is what this data means.
Exactly. So Devansh is saying that it's a self-learning algorithm. Yes, you can say that it's a self-learning algorithm. We provide the input and it learns on its own. Okay, so Dipali has raised her hand. Yes, Dipali?
Sir, it might be said that the capability of a machine to imitate human behavior.
True, well said. Absolutely. So what we are trying to do is, we don't want to do all that work. We want our computer to do it. So what we are doing is, we are creating a program. It's like copying the human brain. So the computer, that particular program is going to do the same task for us. Yes, exactly. Krishna, yes, I saw the thing which you have written in the chat box. It's completely right. It's completely 100% correct. Machine learning is an important component of the growing field of data science. Yes, what you can say that machine learning is a first step towards data science. Okay, so data science is a very broader domain, and machine learning is just a start. It's just a small part of it. Perfectly fine. Perfectly right. Okay, so I guess everyone has understood what do you mean by that. What do you mean by machine learning? So yeah, so as I showed you about the Open Smart Camera task, so this particular app is designed by Google so that you guys can learn more about machine learning through practical experience. because I guess theoretical knowledge and all is not enough to understand a particular subject. So that's why Google has made this app through which you can study machine learning and many other concepts. So now moving forward with the machine learning. So what's the step-by-step procedure? Okay, so first of all, you need to analyze what's the problem statement. What do you want to extract? For example, as I said, I want to differentiate between a cat and a dog. So that's my particular goal. I've set that goal, okay. After that, according to my goal, I'll train my model. What is training of the model? Training of the model is supplying the images of cats and dogs and telling that algorithm that this image is of a cat and this image is of a dog. Okay, and refining until the goals are met. Refining means, for example, there can be a confusion that the sizes of a cat and a dog is similar. There may be a chance. So your program may get confused that how is this possible? This can't be done. So that will give you an error. And how you can sort this error? You can provide, there are many methods, okay. One of the methods is you can provide such images in which they are different, in which cats and dogs have the same size. Okay, that's one of the methods. You can improve the efficiency of the algorithm by many other methods. So this is a very broader topic and it will be covered in the subsequent lectures. So till now, what you need to understand is you need to take care of three things. First, you need to analyze the problem statement. What do you want as the output of that particular program? For example, it should predict whether it's a dog or a cat. Okay, and accordingly you have to train your model using various other models which we will be learning in the subsequent lectures, and then you have to refine it. Refine it as in improving the accuracy so that your model should be 100% perfect. So even if you give the program any image, it should perfectly recognize that this particular thing is a cat or a dog. Okay, so that is giving the application data, and from that data it learns what is the data and could recognize and predict next time. Absolutely correct. So you are going to train him for the first time or the second time, and after that, once the model is trained, it will give you the output and it will predict the values. Very good, very good. So now let's just move ahead. So yeah, now moving ahead. So actually there are two ways to solve a particular problem. Why am I considering this as a problem? This is a problem statement. For example, you're going to classify cats and dogs. Okay, that's a problem statement for you. So there are two approaches. So either you can go for a rule-based approach. What do you mean by a rule-based approach? I'll tell you with an example. I'll use the same example everywhere so that it's quite familiar to you. Okay. For example, I am setting the rules. A dog is 3 feet tall and a cat is 2 feet tall. Okay, the width of the cat will be around 2 feet, the width of the dog will be around 4 feet. Okay, and I can say that the color of the eyes of the dog can be black, the color of the eyes of the cat will be blue. Okay, so what am I doing here is I am defining a set of rules through which my program will predict that this particular thing is either a cat or a dog. Okay, and in machine learning what I am doing is I am training the algorithm. I am just supplying images. I am not defining any rules. Okay, a particular cat can be 2 feet tall or a dog can be 3 feet tall. I am not defining any rules. I am just saying that I will provide you images and you will learn on its own. Okay, so there are two particular approaches to solve this particular problem. Either I define a set of rules or else I'll use machine learning. Okay, so I'll tell you what are the disadvantages of rule-based approach. For example, as I said, there can be there can be one image. Okay, so there can be one image where the sizes of cats and dog can be similar. There may be a chance, or the dimensions or the size of cat and dog both are similar. So in that particular case, if we are using rule-based approach, so the program won't provide us any output because it will be confused, because the dog and the cat both are satisfying the requirements and the rules which were predefined. Okay, so in that case, rule-based approach is not preferable, and we have to shift to machine learning because machine learning extracts more number of features. It may extract some different features, not just on the size and the color of the eyes. It can have several other features as well, on which the machine learning program predicts whether it's a cat or a dog. So always, not in all the cases, but in most of the cases, machine learning is more preferable. So are you guys clear with what I have explained? If yes, then just put a yes in the chat box. And if I'm going way fast, so just let me know. Perfect. The energy in the chat box is just motivating me to extend this lecture to half an hour. Don't worry, I won't do it. Okay, so now I have a small test for you. So now based on your understanding, you guys have to tell me, like, is this particular question correct or not? So here we have a problem statement, okay? Alphabetizing list of song titles, okay? So this is our problem statement, okay? And you have two options. Either you can use rule-based approach, else you can use machine learning. So what will you choose and why? I want answers from you guys. You have to list all the song titles alphabetically. So what approach will you use? Either rule-based, you will define a set of rules, or you will use some machine learning algorithms, and why? Rule-based. Okay, because there won't be any uncertainties. Okay, any other answers? Anyone who would like to unmute themselves and answer this particular question? Guys, it's an interactive session, so you guys can unmute yourself. You can ask us direct questions. We will be answering. Okay then, so yes, perfectly right. Everyone, those who have given the answer, those are perfectly right. Yes, because there are no permutations and combinations. Either and a particular sound can start from A, B, C till 26 characters. So there's no such ambiguity. Okay, so that's why here using a machine learning algorithm is not like it's not worthy. We can use a simple rule-based approach for that. Okay, so ranking of web search results. I think all of you must have surfed the internet. Okay, so this is the problem statement. ML for ranking. Okay, so can anyone of you just unmute and tell me the reason why are you guys preferring ML?
Can I speak?
Hello Ramja, yes?
I can be totally wrong with this, but because I'm very new to technology, it could be that because the Google search involves, qualitatively analyzing various pages, like they have to look for SEO words that match their, search, and there are various permutations involved in it, so machine learning would be better. I'm really not sure of the answer.
No, absolutely. Machine learning would be more preferable because everyone knows we have infinite number of web pages, and to get the web search results, so definitely Google has to analyze each and every page. So it's not a simple task to analyze infinite number of pages. That's why over here, instead of doing it using rule-based approach, machine learning would be more preferable. Everyone, all of you are right. All of you are right. Because it involves prediction, so with the help of ML we can do it. Absolutely right. Absolutely right. Perfect. Perfect. Okay, so now let's just move on to the next question, which is predicting house prices based on location. I think this one is pretty simpler. Every one of you can answer. So you need to predict the house prices based on the location. For example, I'm living in Mumbai right now, and I want to look for a house maybe our campus is going to start, I'm going to search for a house. So I'm using the internet for that, and I need to predict the house prices. So which one I'm going to use?
Can you repeat the question?
Okay, so the question is predicting house prices based on location. Okay, for example, you're going to buy a house or you're going to take a house on rent, and you need to predict, you need to get the prices of that particular location, prices of the house at that particular location. So which algorithm will you use? Either you will go with the rule based or will you use machine learning? That's the question. ML, yes, perfect. ML is the correct answer. Perfect. Machine learning. Yes, it's pretty simple because there are many permutations and combinations. Permutations by mean, for example, I live in Jogeshwari, so I'll definitely search somewhere around Panvel. Okay, there's some other person who doesn't want to stay in Panvel, so he'll search for something else. So there can be multiple combinations. That's why rule base is not preferable over here. Now this one is quite tricky, and this is a challenge for you. Processing online payments. Okay, rule based. Why? I just want to know the reason. Why?
Is there is a specific procedure that you have to follow while doing things?
Exactly. Because online payments are, it's not like we can use it using machine learning, because there are predefined set of rules. Okay, because it involves exchange of money, so that's why it is one of the critical problem statements. That's why over here machine learning is not preferable, because like every algorithm or every program doesn't give us 100% efficiency. Okay, so over here we need to go through a predefined set of rules, and if it matches with it, then only money transfer is possible. So you all are perfectly right, it is rule based. So going with the last one, classifying an object in a photo. I think we just did it right now. ML, absolutely correct. I think you guys must have done this open camera wala thingy. So this is exactly similar to it. We are just classifying. What I did was I just opened my camera and it was showing me that this thing is a keyboard. Okay. So what I did is I just classified an object in particular category. So yes, machine learning is used in this. We can't use it using rule based. Okay. Because like this particular keyboard, there can be something else as well which is not a keyboard, but it somehow looks similar to the keyboard. It has the same dimensions. That's why it's not preferable. Okay, you guys have correctly answered the questions. Okay, so now here's a short video of how you can implement your machine learning model. Okay, so it will just give you an overview. Okay, how you're going to implement your machine learning model, what kind of approach you are going to use. Okay, so as I first mentioned, you need to analyze the problem statement, and then you have to come up with what algorithm I'm going to use for it. Okay, if that particular algorithm or it's all I'll teach you this in the upcoming lectures, but this is just a short overview so that you can you can know what all we are going to teach you in this particular program. Okay, it's just a 2-minute video, so let's just watch it.
How does your...
I hope it's audible.
Yes.
Perfectly fine. Okay, so let's just start. And guys, if I'm going way fast, so just let me know. I'll just reduce my speed, and I'll also answer your questions. So if you guys have any doubts or anything, so just paste it in the chat box, or you can just unmute yourself. Feel free to ask any questions.
your idea become a working machine learning solution? Suppose you have a great business idea, and you've already gone through the effort to frame it as a machine learning problem. What next? How does your idea become a working machine learning solution? The process has 3 phases: data, modeling, and production. In the data phase, you identify the input data that your machine learning system needs to make successful predictions. Data may come from databases, log files, web pages, and even other machine learning systems. Once you identify data inputs and sources, you use statistical tools to draw insights about the data. The better you know your data, the more useful hypotheses you can make. Data rarely comes in an ideal state. Data needs to be collated, possibly by joining different data sources, and cleaned for the machine learning model to work optimally. Cleaner data results in better predictions. For a machine learning problem, you start with the input data and convert it into features. Features are key properties of the data. For a supervised machine learning problem, you transform the outcome into labels. Labels represent the intended output of the machine learning system. Joining data sources, cleaning the data, and engineering the features and labels takes time. Plan on spending a large portion of your time in the data phase. Modeling phase. Along with the features and labels, you set up the kind of machine learning system needed, called the model. Researchers have created all sorts of machine learning models, from simple to complex. Some models classify data. Other models predict numeric values. Tools like Google's TensorFlow support many types of machine learning models for various uses. Before a model can make predictions, it needs training, which is like sending the model to school. First, there are lessons to learn from the data. Along the way, there are quizzes to check knowledge and correct any misunderstandings. In the end, there's a final exam. When training the model, you split the data into 3 sets: training, validation, and test. The training set corresponds to lessons. Here, the model processes data for the first time. It starts to infer patterns in the data to help make predictions. After you've trained the model once, you quiz it using the validation set. Based on how well the model does on the quiz, you may decide to adjust the model settings, or hyperparameters, which are like dials and switches for changing the model's behavior, and retrain the model again to give it the quiz again. The goal is to iteratively find settings that provide the best model quality on the validation set. When the model meets your success criteria, it's time for the final exam. Feed your model the test set. If the model predicts well, it passes the course and is ready for real use. Once your ML system is ready for the world, it's time to move the system into production. For starters, your system may need integration into a product. You need to figure out what this integration looks like and whether your model interacts with users. Models may need retraining on a regular basis with new data to pick up on new patterns or trends. This training could come from new data sets or from interactions with users. The system needs monitoring. This means tracking system outages, errors, data processing volume and speed, and how successfully it predicts results. Machine learning systems also require maintenance. As with any production system, this means fixing bugs, adding features that didn't make it into version 1, and the like. Machine learning specific maintenance could include testing other models and settings to see if performance improves.
Okay, so did you guys understand what they were trying to explain in the video? I know you must not have understood the whole thing, okay, but I guess you must have got a brief idea about it. So let's just continue, and I'll just explain you what all do we have in this particular video. Okay, so here you can see the whole machine learning process. Okay, so the machine learning process is quite similar to like a person which goes in the school. Okay, a kid who is going in the school. Okay, so what we do is first we educate the person. Okay, he does his whole thing, he studies for the whole semester, and at the end what we do is we take the final exam. Okay, so training a machine learning model is somewhat similar to that. Okay, So what we use it, we just focus on the user first. Focus on the user. What I said is analyzing the problem statement. What do you have in the particular problem statement? What you can do? What you should get at the as an output of that particular problem statement. Okay. Once you have properly analyzed it, you define a particular objective. Defining an objective means, okay, you want so you are supplying dogs and cat images, and you want the output to be this is a dog, this is a cat. Okay, so your objective is defined. Like I want this particular output. Okay, this as the output. This is defining the object. Okay. So after that, what you need to do is you need to collect the data. As I said, in a machine learning algorithm, you need to provide the data on which the program will get trained. Sorry for the inconvenience. Just a minute. Okay guys, very sorry for that. Okay, so as I was saying, the first thing is you need to analyze your model. Okay, what you want as the output of that particular model. Once that is done, define your objective. Okay, this is the output. For example, I am having two sets of dogs and cats, and what I want is I want to predict that this animal is a dog or a cat. So that's my defined objective. Okay, once you're clear with the path, now start collecting the data of the dogs and cats. Okay, once that is done, now it's time to train your model. You need to tell him, okay, this particular image is of a dog, this particular image is of a cat. Okay, in this way you will explain the model. Okay, this is how you need to identify whether it's a dog or a cat. Okay, now it's in the final stage. Okay, consider the example that you are going to school, you have studied for the whole semester, and now you're going to appear for the exam. Okay, so this is the exam time in which you need to predict. The model will be predicting the values. Now you have supplied the data, your objective is clear, you have trained the model. Okay, now you have to predict that this particular image is of a cat and a dog. Okay, so accordingly, if you have correctly trained your model, the efficiency is quite good, then it will give you the results. Otherwise, it will give you a different answer. For example, if I've trained my model very well, it is giving me 100% efficiency. It's totally fine. It's 100% efficient. Then if I supply an image of a dog, it will tell me, okay, this is a dog. And if I've not properly trained the model, there are some bugs, there are some errors, then it will say that, okay, this is not a dog, this is something else. Okay, so this is how it works. This is how you need to start from the problem statement till the end. Okay. So I think you guys are clear with this. So if you guys have any doubts, just let me know. Just type yes in the chat box if you're clear with this. If not, I'll explain it once again. Yes. Yes. Okay, so can someone just quickly summarize the whole steps as I said in the chat box? Quickly in the chat box, or just unmute your mic and say that, okay, this is the whole process in 4 to 5 words. That's all. Very good, Kushi. Define a goal. Yes, Shubham. Define a goal, then train your model. Yes, Vinay. Providing data, then training, then testing. Yes, train your model. Exactly. Training and testing. Perfectly right. Features and labels. Very good, Kiran. Very good, Kiran. Excellent, guys. Excellent. So I guess you guys have got an idea of what this Devansh, goal setting, collecting data, then training, then testing, then again debugging. Perfectly right. That's a great answer, Devansh. Okay. I guess you guys have an idea about what is actually machine learning. So now it's like, what can machine learning do? Okay, so machine learning can be implemented in various fields. Actually, machine learning has its applications in each and every sector. For example, let me give an example. I think you guys must have seen disease prediction applications. Okay, so this is one of the new things. Okay, so what does a disease prediction application do? Okay, you need to provide some inputs about fill some health fields, and based on your health fields, the data which you have entered, so the application gives you an output, like whether you have this particular disease or not. Okay, so this is one of the applications in the field of health tech. Okay, in fintech as well. Fintech means related to finance. Okay, in that particular field, I think they can predict the stocks. Okay, so at this particular time, the prices of the stocks will be higher. At this particular time, the prices of the stocks is quite lower. Okay, so now based on some machine learning algorithms, so the program can tell you, okay, at this date, okay, on 16th November, the share price of this particular company, for example, Tech Mahindra, is going to be high. So how did he predict it? Using the previous data which he already has, the program already has. Okay, so this is how they predict. He like using machine learning, we can predict like at this particular time we can have like the share price will be this. Okay, so this all is done using machine learning. So now moving on with machine learning and artificial intelligence. So machine learning is what you can say is a subset of artificial intelligence. The broader domain, I think you guys know Siri, okay, and you guys must use Cortana, which is used in Windows, okay. So those all are all are made using artificial intelligence, okay. So that's a broader domain, and machine learning is just the first step towards artificial intelligence. And now moving on with ML. So what does ML comprise of? Like ML is used in big data as well. ML is used in ML uses algorithms. ML uses data. So it somewhat comprises of all the things: big data, algorithms. Okay. So these all are just applications of machine learning. Okay. So I want you guys to give me an example of applications of machine learning which you see in your day-to-day life. Okay, just one example. I want one unique example from every person who is in the meeting right now. Just write it in the chat box. Google Maps, excellent, winner, excellent. Weather prediction, perfect, Daksh. Streaming services like Netflix. Yes, autocorrect. Perfect example, Tyler. Autocorrect, yes, definitely. YouTube. Social media feeds, exactly. Social media feeds, web search. I think you guys must have noticed, like, if you are searching on your Instagram feed about clothes, okay, you have searched it a couple of times, then you will see that there will be some posts which will be related to clothes on your feed, okay. So that's the Instagram algorithm. It analyzes your search. Okay, the algorithm analyzes your search and it gives you that particular post only. So only you will find many cloth related posts on your feed. So that's the algorithm of Instagram. Recommended search, email spams, face log, excellent. Yes, face log. Facebook ads, yes. You must have seen that if you are searching on Google about clothes or any, for example, you're searching about laptops, okay, you'll see that in some applications you'll get ads which are related to laptops. So what is Google doing actually? He is analyzing your search history and accordingly he's showing you the apps. Facebook, every company does that. Categorization of objects, landscape on Google Photos, excellent. People you may know, that's an excellent example, Gayatri. Spotify, perfect. Cookies, okay. Based on music taste, it will give us playlist. Yes, exactly. Spotify and Gaana, Hangama and all, these applications do that. Perfect. Smart Assistant, yes, Kunal. Siri, Cortana, Google Assistant, these all are very good examples. Amazon search engines, excellent, Gagan, excellent. So I think you guys have an idea about what machine learning is and what we are going to do in this particular machine learning bootcamp. And you guys will be building your first machine learning project over here. Okay, so that's all from my end. And now Smith will continue. Smith, are you ready?
Yes, Tushar, absolutely. Hello everyone, I'm Smith. I will be continuing with Python, and I just wondering if anyone is new to programming or haven't done anything related to any kind of programming or coding. Is there anyone who is totally new? Okay, Krishna, Radhi. All right, we have few beginners. Okay. Yeah, great. So first of all, this would be the best time to get started with the coding. Like it will be beneficial in every kind of aspects in your life, in personal life as well. Because in today's world, we are all uh, like surrounded by technologies, right? And having much senses of what happening in the background is much more useful. It helps in automating certain tasks in our daily lives. So it would be a great start here, and I will jump start into the programming, like from the basics. From I will be using Python. I can see some my friends are here who already have knowledge of some programming language, but be bear with me. We will start from very basics. So anyone with no any experience with any kind of coding, whatever, they will be able to cope up with it and will really have fun. So let me share my screen. I hope my screen is visible.
Yes, Smith.
Yes.
All right. Is whiteboard visible?
Yes, the screen is visible. I think it's frozen. Can you share it again, Smith? Hello, Smith. Smith, you can share it again.
I think there is some voice lag. Just a moment.
Yes, I think your screen is visible now. Hello, Smith. Hello, Smith, you're on mute.
Am I audible now?
Yes, you're audible.
Okay, great. Can you see my screen?
Yes, it's visible.
Okay. Okay, now whiteboard is visible, right?
Yes, the whiteboard is visible. Is it visible to others?
Yes, yes.
Okay. So today we will be learning some basic concepts about Python and basics about programming in general, and what kind of logic we use while programming, and some basic stuff, right? So if I see many people are new to programming, so Python is a language we use to code something. Like it's pretty much similar to English as we write, but it has some structure which we have to follow so that the computer can understand. There are some engines in background that understands and converts the code. That is later part, but we will focus on the English logic. Like similar to English, we have rules, some basic, we call it syntax, which we have to follow in order to code our required functionality. Okay, so in Python there are few data types. Now what data type means is what type of values we can use while programming. Like we can use numbers, like we can use characters, letters, etc. So in English we have numbers and characters and some symbols. So in programming language, and particularly in Python, there are a few more data types which we will discuss. So the first one is numbers. There are two different parts: integer, like only single number, or without any fractional part, we can say. And there is a float number. Float numbers are basically numbers with decimal point and fractional values. Okay, so these are the possible numbers. Like we can use. Can you see my cursor, right? Okay, so we can use also scientific notation for representing numbers. We can use negative numbers as well, and fractional parts. These are few examples. Then we have strings. Strings are basically collection of characters. Like when we write our name or we write any sentence, that is collection of characters, right? But there is some rule with strings, with collection of characters. If we have to write any string, we have to follow certain rules. These are the three rules where whenever we have to write something, we have to write it in the quotation mark. Strings are in the quotation marks. It can be single, double, or triple quotations. Okay. So, for example, if you want to write some letters or some characters, then we prefer single quotation. Or we have to write any word, like it can be any word, literally. So we also prefer single quotation mark for it. But when it comes to a sentence, where we contain spaces and there are a lot of characters, then we prefer double quotations. And a single quotation in this example, it's okay. We write single quotation. So preventing any confusion, the outer quotations would be different than the quotations used inside the sentence. So it's just to prevent any confusion, we follow single quotation inside sentence and double quotation for sentence on the outer part. Okay, so let's jump. Okay, next we will start actual coding, right? So I want everyone to open your browser. If you are joined from computer, open your browser and the browser. If you are using mobile phone and if you have any computer around you, then please get it up and do programming with me. Like I will be doing a live with you, so you can practice with me right now, and I will also provide these notes and a few examples after the session ends, and I will like you all to code with me. So are you ready with your browsers open?
So guys, as I said, this is not going to be just a theoretical session where you will get all the theoretical knowledge. We are also going to implement this in real time. So just be ready with your browsers, okay? And Smith will be sharing a URL in the chat box. Okay, just click on that URL and you can code. So there's no need of having any application or any software in your PC. For example, if your laptop is of a smaller configuration, 4 GB RAM or something, it does not support any software, that's not an issue. You can just use a browser for that, browser for programming, that's all. Okay, Smith, so just share the code in the chat box, and I think everybody is ready with it. So can I get a yes in the chat box? Excellent, excellent. I'm very happy to see the energy. Perfect. So I'll just give you a brief idea of what we are going to use in this particular bootcamp. So this thing is known as Google Colab, which is created by Google. What you can say is, okay, let me just give you an idea, those who are quite new to programming. Okay, so in order to compile or get output of a particular code which you have written, we use something known as a compiler. Okay, so for compiler, we need to download certain softwares or download that particular compiler on a software. But here, Google Colab is an online compiler which is created by Google, and you can compile your code with one click. That's all. Okay. So Smith, please share the link in the chat box so that people can do it. Or else you can also do it. Just type Google Colab. Okay. Click on the first link and click on create a new notebook, as you can see on the screen. And the best thing about Google Colab is all these files are going to be saved in your Google Drive. So if you want to revise your machine learning concepts, then what you need to do is just go to your drive and just open this particular collaboratory. So as soon as you create a notebook, what you can see is a new folder is created in your drive, which is known as Colab notebooks. Okay, so all your Colab notebooks, all the notebooks which you have created in it, that will be visible. And you can access it anytime. Okay, so be ready with it, and all the best to all of you.
Alright, so there are just 3 steps to get started with coding. First, open your browser and write Google Colab, enter the first link, and you will be prompt up with this interface, and there will be no files like this. It's okay. So once you have done till here, just click on new notebook. And you will get a new environment set up for your session, and it's all like pretty much this much only. You are ready to code. So you should be prompted up with this interface, and don't worry about the backend things. it will automatically save your work in your drive if you already have logged in the browser with your email ID Google account. So just rename the notebook by whatever name you will prefer. Python Basics. Is everyone ready? You can type yes in the chat box, so we can proceed further. All right. So many yeses. Okay. So as we seen, there are many numbers. There are different type of numbers that we can use, and while programming, there are few more things that we have to consider. If you didn't like maths in your high school, don't worry, it is pretty much very much easy, and like it's as easy as k equals to 10. Okay, so here we store a value, 10 is our value, and a is a container which contains our value. We call it as a variable. Just remember some terminologies, or you can also write it somewhere in your notebook if you have a. And this is pretty much it. We have saved some value in our computer. Okay, we can use it like print a. It will be take some time while doing first time. It's showing connecting. Okay, so you can see that here this image, this icon, whatever is shown here, that's our output, and whatever we write in this section is our code. So here there are few things like what is this print. It's okay, like it's similar to English, we can understand by reading it, but this is something that we have to follow while doing some stuff like printing, like getting input, and then we will cover all things one by one. So here what we just did is we created a box or container, we can say. We call it a variable. So from now I will call it a variable. So I created a variable and give some value equal to 10. Now if you have any background in any programming language, then you might have found it easy. But we don't have to write any type of indication like are we going to write integer value, floating value. It will store whatever we give it to store. So once here it is storing 10, and here we are asking it to print. Okay, like this is print statement, and this brackets, this parentheses are containing some value. Like if we are telling computer like print something, then we will enter something here, like what we want to be printed. So we are passing this container, like whatever is in this container, just print it. Whatever is in this variable, just print it out in the screen. So we have 10. Okay, then we will see a few more examples. Equals to 3.5 print a. It will print whatever we tell it. Then we can also perform some operations on the numbers like as we do in maths, as we calculate on our paper with pen, we can do those things, basic things, with writing code, and the computer will solve it for us. Let's do addition is equals to 5, b equals 5. Okay, we can keep it 3. Okay, so just remember there is some structure constraint. Like we can't write everything in the same line. As we prepare in the notebook, we write a equals to b, and besides that we can write b equals to 3. But here we have to follow some structure. So we have to write all these things in new line. Just see and try to remember these things, like how we are writing any new variable or any new container on which line, how we are writing print statement, or how we are writing any statement, because that structure would be followed throughout whole session and throughout your programming journey. So it is different in every programming language, but Python follows like if you have space in front and you writing something here like c equals 4, then this is not a good practice of writing. Alright, so what we are doing now is doing the summation. Okay, so c equals to a plus b, and remember if we write in capital, it will give an error. Why? Because Python is a case sensitive, means small b and capital B are totally different entities. Alright, so we will write b and then print c. Can you see it? It does addition. We can perform multiplication. Just a moment, it's taking some time. Okay, so we can see it does multiplication for us. There are a bunch of other operations, mathematical operations, which we can perform, like addition, subtraction, multiplication, division, and we also have some other new operations which we do not perform by hand generally, which is this percentage symbol. What it does is it gets us the reminder after division. Let's see an example. 5, first we'll see division. 5 divided by 3. What we get is 1.6667. Okay, so we can see here that there is 1 and there is some reminder left out. Like when we divide 5 by 3, then we know that 3 1s are 3 and 2 is the remainder, right? So now we will get that 2. You can see you can also perform by side and give some different values here, and it will perform all the time. So whatever value we give, just remember, give it a number for division and other mathematical operations. So moving further, we have strings. Okay, as we discussed, there are some rules for strings. We have to present in quotation marks and And similarly, we can also create a container for storing the strings. So, and one flexibility here is, as we have considered A as a placeholder, as a container, as a variable, we can name it anything. Like this is my string. It will act as a container. And equals to, we call it an assignment operator. We will see furthermore what specific things it does and what role it plays in places. But for now, just see the functionality of how we are performing these things. Like it is very, very similar to what we do generally in maths with hand, right? So we can store string, like let's consider math. So it is store string, and similarly we can also print this. It will show whatever it is containing. So let's create few more strings. See, if we didn't print, it does nothing. It shows nothing. We have to explicitly tell it that print something, and we have to give it that what we have want to print out. Okay, so as we give here the container name, like whatever inside this container, just print it out. Okay, and one thing we can see is if there are if we have created container on any block, we can use it on the other blocks as well. Like in this block, I have created one string, right? So we can use in any other container. Like if I print here, then it also shows me the result output. So you can use it multiple times. You can refer to these strings, this A again. Okay. So here are some examples like how we store strings. Now there are some properties related to strings. Now this is simple, like this we know, like it is very, very simple. So now comes the actual power of programming, actual power of coding. So what things we can perform? If I want to see what is this character, or I don't know the strings, just I want to know which character is at position number 3. Okay, so what I can do is my string, then we use square brackets to mention position. We call it index. We want to see what is there in the 3rd position, or we can say what is there in the 3rd location or 3rd index value. So we will see what is index first. Just see what it outputs. It is showing age. So does anyone know why it is showing age here? Like we, as I mentioned, we want to see what is there on the 3rd position, but it is showing age which is on the 4th position. So does anyone know why it is happening?
Because index starts from 0.
Yes, exactly. Here, see, when we store the string now, it stores like this. Every character has some position value assigned to it. So like T, U, S, H, and the one thing we have to notice is the indexing starts from 0. What this index means, these all characters stored in different sub boxes or sub containers, we can say, and these sub containers have name. and that is what we call index, the name of this sub-container. So this naming starts from 0, and one thing to notice here is it is we use numbers for naming it. Like we don't use A, B, C, D, right? So we use this numbers, and it starts from 0. So this box value is address is 0. If you want to see what is in this particular sub box or sub container, then we have to use 0. Then 0, 1, 2. So you can see we have to remember this, and while retrieving, I wanted the 3rd position, but it is giving me 4th position, right? Just a minute. Right. So as we write 3, it shows me H, whatever is here, 2 sharp. Okay. So you can now see that if we want any position, we have to start indexing from 0 and accordingly see at what index it will be our required character. Like if it's 3rd position, then we have to give it as 2, like -1. Okay. And one thing to notice here is it also provides us negative indexing. Like if the string is very much large and we have to consider some characters from the end, then we can use negative indexing. And negative indexing starts from last part, and it starts from -1. Here, one thing to remember, while giving negative index, it doesn't start from 0. It starts from -1. The -1 is the last character of the string. Okay, so we will try this string -1. Just a minute, I think it's reconnecting. This collab is something that just consider any other computer running in the cloud or somewhere else in the world, and we can access this that computer using this interface. Like whatever we do here, it performs those tasks on other computer in the cloud. That is something else you can study further. So let's see, here it is showing us L. This is the last character. Okay, so similarly, it will we can refer any position from last with negative indexing. And while using positive indexes, when we want something from the starting index or something using positive index, then we have to remember that it starts from 0. Okay. Then what we have next? Alright. We see how we get or see what position contains which character. So there are few other properties as well. As we can see, we can if you want to see what is that character at what position, we can see that, but we cannot change this. See, if I write my string, then it shows me whole string, correct? Okay, but when we want to get only one particular characters, we use indexing. Now there is another properties like immutability. These strings are immutable. Like we cannot change any character. We can only see characters, like as we have seen here, H and L. Okay. So if you try to alter any character, like we will try to alter first character equals R, it will show us an error like this. String object does not support item assignment. What we are doing is assigning the first
we try to replace this T with R, but it is showing error because in strings we cannot alter anything after we have assigned it. After we have assigned any container, we cannot change anything inside the subcontainer. But we will see some data types supports that and allows us to alter those sub containers as well. We can change those values, but we will see it in later. Okay. So another property is concatenation. Okay. So let's see an example. Here we make a container first name which contains a first name of anyone. You can write your name, Tushar. Okay. Then we make another container last name which contains last name of Tushar, that is Sharma. Then if we print this container, individual container, then it only shows that container. But if you want to combine both containers, if you want to see a full name like print,